Trigonometry has a lot of applications. It's incredibly useful. And the first place to start is to understand sine, cosine, and tangent. So keep watching. Welcome to Math Bytes. I'm Allison. And today we're talking about three of the trigonometric functions: sine, cosine, and tangent. Right triangles were used to define trigonometric functions in the 16th century. So let's take a look. We have a right triangle here. Now, we like to talk about whether the side of a triangle is opposite or adjacent to a particular angle. For example, in a right triangle, the hypotenuse, the longest side, is always the side opposite the right angle. So let's mark our other angles here. Let's mark an angle and call it theta. Now side A is adjacent to theta, and side B is opposite to it. Let's mark our other angle and call it phi. Now side B is adjacent to phi, and side A is opposite to phi. Now this is important because we use this to define our functions. So we have, for an acute angle theta, the sine of theta is equal to the length of the side opposite theta divided by the length of the hypotenuse. The cosine of theta is equal to the length of the side adjacent to theta divided by the length of the hypotenuse. And the tangent of theta is equal to the length of the side opposite theta divided by the length of the side adjacent to it. These are the definitions of these three trigonometric functions, and we often abbreviate them like this: O over H, A over H, and O over A. Now, let's take a look at an example and put this into practice. Okay, let's take a look at an example. We have a right triangle here. The lengths of the sides are 5 and 12, and we're going to find the sine, cosine, and tangent of both of our acute angles. Now, before we start, though, we have to find the length of the hypotenuse, and we can do that with the Pythagorean theorem. The Pythagorean theorem says that the sum of the squares of the sides equals the square of the hypotenuse. In other words, a squared plus b squared equals c squared. So, in our case, that means 5 squared plus 12 squared equals c squared. Okay, so that gives us 25 plus 144 equals c squared. I add those up and I get 169 equals c squared. Take the square root of both sides and I get that c is equal to 13. Therefore, the length of my hypotenuse is 13. Okay, now I'm ready to go. Now, let's find the sine of angle theta. That's equal to the length of the side opposite divided by the length of the hypotenuse. Now, in this case, the length of the side opposite theta is 5, and the length of the hypotenuse is 13. So the sine of theta is 5 over 13. The cosine of angle theta is the length of the side adjacent to the angle divided by the length of the hypotenuse. So in this case, the length of the side adjacent to theta is 12, and the hypotenuse is 13. So the cosine of theta is 12 over 13. The tangent of theta is equal to the length of the side opposite divided by the length of the side adjacent. So in this case, that gives us 5 over 12. So the tangent of theta is 5 over 12. That's it. Now, let's do the same thing for our other angle, phi. The sine of phi is equal to 12 over 13. The cosine of angle phi is equal to 5 over 13. And the tangent of angle phi is equal to 12 over 5. Now you'll notice for each of our acute angles, the sine and the cosine are equal to each other, and vice versa. And their tangents are reciprocals. Okay, let's take a look at a different kind of example. Theta is an acute angle, and we're given that the cosine of theta is equal to 3 over 5. What is the tangent of theta? All right, first let's remember that the cosine of theta is equal to the length of the side adjacent to the angle divided by the length of the hypotenuse. So let's draw a right triangle so we can see this a little bit better. Okay, so we have our right triangle. We'll mark one of the acute angles theta. It actually doesn't matter which one. The side adjacent to it is 3 because the cosine is 3 over 5 and the hypotenuse is 5. So we have to make sure to mark those two correctly. Now, we need to find the length of the other leg, and we can do that with the Pythagorean theorem. So the Pythagorean theorem says that a squared plus b squared equals c squared. In our case, that means that 3 squared plus b squared equals 5 squared. So we get 9 plus b squared equals 25, subtract 9 from both sides, and we get that b squared equals 16. Now we take the square root of both sides, and we get that b is equal to 4. So now we have the length of all three sides of our right triangle. All right, so now we need to know what the tangent of angle theta is. The tangent is equal to the length of the side opposite divided by the length of the side adjacent. So the length of the side opposite to theta is 4, and the length of the side adjacent to it is 3. So the tangent of theta is 4 over 3. And we found that by just knowing what the cosine was. We could do the same thing if we just knew the sine. Trigonometry is used in oceanography, astronomy, civil engineering. It is incredibly useful, and it's well worth learning, and this is the right place to start. That's it for this episode of Math Bytes. If you like our videos, why don't you subscribe to our channel? And if you have a question for us, just send us an email. We're at contactmathbytes@gmail.com, and I will see you next time.